The James Webb Space Telescope was built to photograph the darkest corner of the universe. The cosmic dark ages, a period after the Big Bang when no stars existed, no galaxies had formed, and the entire universe was a cold, black ocean of hydrogen, with not a single point of light anywhere in it. Webb pointed its mirror into that darkness, expecting to find almost nothing. A few dim smudges, a handful of faint sparks at the very edge of detection. Instead, it found over 100 times more galaxies than the models predicted. Not 20% more, not double, 100-fold. The early universe was not empty, it was already on fire. And the most distant object in that blaze, a galaxy called MOM-Z14, is carrying a chemical signature inside it that should not exist for another billion years. The timeline is wrong, and nobody can explain how. This is the discovery that is rewriting the first chapter of the universe in real time. If this is your first time here, we break down the most extreme science in the universe. Drop where you're watching from in the comments. I want to see how far this one reaches. To understand why this discovery broke the models, you need to understand what the Dark Ages actually were. Picture the universe a few 100,000 years after the Big Bang. It is a fog. Not a cold fog, a blinding fog of light. A thick soup of hydrogen and helium so dense with loose particles that a beam of light cannot travel in a straight line before it slams into something and scatters. The whole universe glows. Then it cools. The particles settle, the soup clears, and that ancient glow fades away into the dark. Once it fades, there's nothing left to replace it. No stars, no galaxies. Nothing has ignited yet. For a long stretch of time, hundreds of millions of years, the entire universe is a cold, black ocean of gas, with not a single point of light anywhere in it. Astronomers did not pick the name Dark Ages to sound dramatic. They picked it because it was, as far as anyone could tell, thus literally true. Then somewhere in that darkness, the first lights switch on, the first stars, the first clumps of gas heavy enough to collapse under their own weight and catch fire. The dawn, the very first sunrise in the history of everything. That moment, that flip from a dark universe to a lit one, is the single hardest thing in all of astronomy to actually see. It happened so long ago and so far away that the light has been stretched and dimmed almost to nothing by the time it reaches us. Catching it is the reason the James Webb Space Telescope exists, and when Webb finally looked, what it found was not what anyone predicted. It was the opposite. In the spring of 2025, a team led by astronomer Rohan Naidu at MIT was combing through Webb's deep images, hunting for candidates from the earliest era of the universe. They were running a survey with a name that tells you exactly how skeptical they were going in. They called it Mirage or Miracle. The whole point was to sort the distant smudges into two piles, the real galaxies and the tricks of light, dust and noise, the mirages. In this line of work, most of the time you bet on the mirage. The universe loves to fool you. A single fuzzy red dot at the limit of your instrument has 100 boring ways to lie to you. One object kept refusing to behave like a mirage. It sat in a patch of sky in the constellation Sextans, below a certain wavelength of infrared light. It simply was not there at all. That sounds like a flaw. It is actually a fingerprint. When a galaxy is so far away that the expansion of the universe has stretched its light to extreme degrees, the short wavelengths get cut off completely, absorbed by the hydrogen the light passed through on its 13 billion year journey. The light just stops below a hard line, like a wall. Astronomers call it a Lyman break, and this object's wall was sitting almost impossibly high, one of the sharpest, highest breaks anyone had ever seen. In April 2025, the team did the thing you do when you cannot believe your own eyes. They pointed the telescope back and took a spectrum. A spectrum splits incoming light into its individual colors, and buried inside those colors are lines that act like a barcode for the object. That barcode tells you exactly how far the light has been stretched, and stretching means distance, and distance means age. There is no faking a spectrum. It is the difference between thinking you saw something and knowing. The number came back, 14.44. Redshift is the measure of how much the universe has expanded since the light left its source. The bigger the number, the longer the light has been travelling, and the deeper into the past you are looking. A redshift of 14.44 means we are seeing MOMZ 14 as it was, just 280 million years after the Big Bang. 2% of the universe's current age. Here is a way to feel how early that is. Take the entire history of the universe, all 13.8 billion years, and squeeze it down into a single calendar year. The Big Bang is the first second of January 1st. The dinosaurs do not show up until late December. All of human history fits into the last few seconds before midnight on New Year's Eve. MOMZ 14 is shining at us. From January 8th. The universe was barely a week old. It had no business being interesting yet. This is now, officially, the most distant object known to humanity, the oldest thing any human being has ever laid eyes on, and that alone would have been a headline. But the distance is not what stunned everyone. The distance was almost the boring part. Remember the prediction? Dim, small, rare, a few faint candles in an enormous dark room. MOMZ 14 is none of those things. It is luminous, aggressively bright. The kind of bright that should take a galaxy hundreds of millions of years and many generations of stars to build up to. It has an absolute UV magnitude of -20.2, comparable to galaxies that have had far more time to develop, and it is not a freak accident. That same survey, scanning across a tiny sliver of sky, found that bright galaxies at this impossibly early age are not rare at all. The number of them runs more than 100 times higher than the models predicted, not 20% more, not double, over 100-fold. Imagine standing at the edge of a forest at night. You are certain it is empty. You sweep a single flashlight across the dark and catch 100 pairs of eyes shining back, where you expected to find none. That is the feeling in the field right now. The early universe was not a quiet, half-empty room with a few faint candles flickering in the corner. It was already lit up, already roaring. The lights came on far earlier and far brighter than anyone thought was physically possible in the time the universe had to work with, as Naidu himself put it. With Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted. The telescope did not gently revise the theory, it drove a truck through it. But the brightness is not the strangest part. The strangest part is what is inside the light. Because when the team split the spectrum apart, they found a chemistry that does not add up. Stars are factories. They forge heavy elements in their cores, then die and scatter those elements into space. The next generation of stars gets built from the enriched ashes of the last. It is a slow process. It takes many cycles of stars being born, living, and dying to load a galaxy up with heavier elements. With only 280 million years on the clock, the universe simply had not had time to run many of those cycles. There should not be much heavy material around yet. The early universe was supposed to be almost pure hydrogen and helium, chemically clean, barely touched. Except MOMZ 14 is rich in nitrogen. Strangely rich. Its ratio of nitrogen to carbon comes in higher than our sun's, and our sun sits in a galaxy that has had more than 13 billion years to cook. A galaxy that has barely been alive for the blink of an eye somehow carries the chemical signature of something far more mature. As Harvard astronomer Avi Loeb put it, the nitrogen we are seeing simply cannot be produced by normal stars. In the time available, normal stars cannot do it, so something abnormal had to. And the only candidate left on the table is something no one has ever seen. MOM-Z14 is not being treated as a one-off curiosity. It is being treated as the brightest member of a whole population we did not know was there, the leading edge of a crowd. And that crowd is the real story. Webb keeps pushing the horizon back, and each time it does, the early universe turns out busier, brighter, and faster than the time before. The record for the most distant galaxy has been broken again and again in just a few years. GN-Z11 in 2016, JADES-GS-Z14-0 in 2024, MOM-Z14 in 2025, each new champion lasting only until the next deep image comes in. We are not slowly confirming what we always believed. We are repeatedly discovering we were wrong in the same direction, over and over. And in science, that pattern is usually the sign that something underneath the theory needs to change. Not a small adjustment, not a tweak, a structural revision of how we understand the first few 100 million years of cosmic history. The researchers who found MOM-Z14 wrote that Webb is carrying us closer to the era of the very first stars, the actual dawn. MOM-Z14 shines at us from 280 million years after the beginning. The first stars are thought to have ignited maybe 100 million years before that. We are now genuinely close to that line, close enough that you can almost feel it. And Webb will not be working alone for long. The Nancy Grace Roman Space Telescope, carrying a field of view 100 times wider than Webb's, could launch as early as late 2026. It is designed to sweep enormous patches of sky and flush out hundreds more early galaxy candidates, for Webb to confirm one by one. Between them, Roman finding the candidates, Webb confirming the spectra, the frontier that took decades to inch toward, is about to crack open all at once. A few more records, a few more impossible galaxies, and the telescope built to find the first light in the universe may actually find it, not imagining it, not modelling it, photographing it. What unsettles you more, the 100 times more galaxies than predicted, or the nitrogen that should not exist yet? I want to hear which part got you. Drop it in the comments. If this is your first time here, you know what to do. See you at the dawn.